Okay, so we're going to be going over energy pyramids. This should be your second PowerPoint. So you should have already done the food webs first, and then you come and do this one. Make sure you are jotting down on your guided notes, filling in the blanks as you are going through here. So energy pyramids, so your essential question is, how is the flow of energy through the energy pyramid diagrams? Answer question 1 and 2. So we know that energy in a living system, this is already a review from the first PowerPoint, but I want you to actually fill in the blanks on this one. So all living things need energy. We've already talked about that in photosynthesis. Energy made by plants through photosynthesis is transferred to an animal that eats it. So the organism then transfers that energy to the next organism which actually eats it, and so on and so on. And so that's why it's considered a food chain, right? So we can also put this in an energy pyramid where you can actually see the different levels. So how is an energy pyramid actually organized? So the feeding, so we call this thing called a trophic level. So each thing has a trophic level, okay? So your lowest trophic level will be on the bottom, and then on top it will be the second one, and the third one, and then maybe a fourth one. So the feeding position in a food chain or an energy pyramid that an organism occupies based on what it eats. So energy decreases from the lower to higher of the trophic levels. So the first level, kind of like, remember in our lab, we did this. So this will have the most energy, then this one have the second to least energy, and then this one will have the least energy, okay? The biomass, or the living or organic material, decreases from lower to higher trophic levels, okay? So what that basically means is when things start to decompose, then as you go from lower to higher, the trophic levels, you'll end up getting the trophic levels start to decrease as well. All right, so think about it. So, is the energy flow of an ecosystem affected in places like Alaska where they experience long periods without sunlight? Explain your answer here. So, think about photosynthesis, and then think about your knowledge that you've obtained thus far of energy transfer, and then jot down an answer here. Go ahead and pause the video and do that. Okay, so you should have answered the question on slide 5. Now let's move on to producers. So we know that producers get their energy from the sun, right? That is like your grass and your plants and so forth and so on. They make their own food through process of photosynthesis, and this is what we call an autotroph. And that autotroph means it makes its own food automatically. So looking here, which level is the energy pyramid represents the producer? So type your answer here. All right, so now let's talk about consumers. So consumers are unable to make their own food. They have to consume something, okay? So heterotrophs cannot make their own food, so they have to eat other things like plants or animals. Go ahead and explain which level is the energy pyramid represents to consumers. Hint, there may be more than one. All right, so let's talk about primary consumers. First level consumers are also known as primary consumers, and these are normally your herbivores. We've already talked about this plenty of times in our warm-ups, so forth and so on. They cannot make their own food, so they have to consume plants because they're herbivores, right? And they're also known, of course, as heterotrophs because they can't make their own food. So here you should have told me which level is a primary consumer, okay? And you should not be doing this in present mode, otherwise it won't let you type on it if you're in present mode. So you have to be out of present mode. All right, next is secondary and tertiary consumers. So each primary consumers at each other, sorry. So some examples will be your carnivores who eat other animals, or your omnivores who eat both plants and animals. And then, of course, they're heterotrophs as well. So go ahead and figure out on this trophic level pyramid right here, which trophic level shows me a secondary consumer and which one shows me a tertiary consumer. And then last, you'll have something called a quaternary consumer. So this is your ultimate apex predator, okay? So this is the top of the food chain, animals upon which nothing preys on. So for instance, if you were remember when we had the African ecosystem for our lab, and a lot of you guys had the cheetahs and then the lion. So the cheetah would have been your tertiary consumer, and your lion would have been your quaternary consumer, because it's an apex predator. Nothing preys on the lion. It's the top of the food chain. Animals upon which nothing preys on. It's typically a carnivore, and it's also, of course, a heterotroph because it has to consume its own food. So looking at these trophic levels, which one is your quaternary or your apex predator? Those terms are interchangeable. Here, what I want you guys to do is use these things here and move them. So build a pyramid that includes each trophic level in their correct location. You'll have 4 pieces left over. So you should be using these, and you should also be using these, and you're just moving them over, okay? So they can drag, and you're just dragging them to where you want them to go and so forth, okay? All right. So here, I want you guys to think about a forest food web. Use the energy pyramid template right here to tell me what would each of these things be, okay? So what will a producer be? What do you think who a primary consumer be? So you should actually name me things. Like here, you could say a tree or something, right? Here, you should be giving me what a primary producer in a forest will look like. And remember, you did this. It was a forest food web in your lab playlist. So with all of the cards, if you wanted to go back and look at those, or you can just use your own knowledge. All right, so now let's talk about decomposers. And decomposers are your garbage man of the ecosystem. They're active at each level of the pyramid. So I'm going to go back to here and show you. So your decomposers will be alongside of the pyramid. We just put them here because they'll be active with the producers. They'll be active with the primary. They'll be active with the secondary, tertiary, and quaternary, okay? So they're active everywhere. So what normally scientists do is they'll put them on the edge of it, so slanted. And these actually break down dead organisms and return nutrients back to the environment. So here is your energy pyramid. So an energy pyramid shape shows how the amount of useful energy that enters each level. So your chemical energy in the form of the food. So remember that each energy level, it decreases as it is used by the organism in that level. So for instance, the giraffe will have less energy than this tree. And then the lion will have less energy than the giraffe, okay? So what happens is as you go up, your energy decreases, okay? As you go up the pyramid, your energy starts to decrease. I want you to read this, okay? So the energy pyramid is frequently used to model the flow of energy between trophic levels. However, as with any model, it has its limitations. For example, the pyramid ends at the top level. This might suggest that the flow of energy stops at the top. Think about it. Is that really true? What happens to the energy from the top trophic level? Think of another model or example that could represent the flow of energy in living systems. I want you to think about that question or those multiple questions and type in your answers here, okay? Be as precise as possible. It'll only help you. All right, so here is what we talk about with the breaking down of energy, okay? So this is similar to what you guys did in your lab. So the amount of energy in every level decreases by about 90% as you go up the trophic level. So the energy is measured in kilocalories or kcal or even joules. So it can be measured in either one. 1 kilocalorie equals 4,184 joules. And this is something that you'll learn in chemistry. Nothing you really need to go really into. You just need to know that joules is the kilocalorie or joules are the units that go after it. Just like grams, pounds, so forth and so on. This is just a unit that energy is measured by. So approximately what percentage of energy is passed on to the next trophic level? Hint, we did this in our lab. You just type the answer in there. All right, so here I want you guys to do the same thing here. Build a pyramid based on the different levels of energy that should be on there, okay? So think about what should be at the bottom, here, here, and here. You'll have 4 pieces left over. Again, you'll have 4 pieces left over. All right, so here, get ready to do some math here. So you have 5,500 joules. What I want you guys to do is calculate each one as you go up, okay? So use the provided text boxes to type in your answer there. So remember, 90% is lost. So therefore, only how much? At this point, you should have said 10%. Only 10% is transferred. So remember, an easy way to do this is knock a 0 down. So what should be here? Knock a 0 down. What should be here and then here? Move 1 decimal place over, rather. Okay, So here, I want you to think about it. So that is a lot of energy that's not being passed on from organism to organism. We said that we lose 90% of it. Take a moment to brainstorm where you think this energy may go. Do not go to the next slide until you have at least attempted. There's no wrong or right answer. There is a right answer, but I'm not counting you off if you didn't get it correct, okay? So just type in where you think that ultimately that energy goes, okay? So here's the next slide. You shouldn't have peeked, but now that you've already typed in your answer on the previous slide, you can move this out of the way and finish writing your notes, okay? So where does this energy go? So remember, energy cannot be destroyed. Energy is used up by the animal's metabolic processes. So your body uses a lot of the energy where you're where you're producing cells in your body. Maybe you cut yourself. That takes energy for your cells to reproduce each other. Maybe you're running around, like if you're an athlete or something, or maybe you're just simply walking. Those things take energy. When you're eating, that takes energy. Finding mates take energy if you're in the wild. Escaping danger if you're in the wild. All of these daily activities take energy. And so that's where the 90% goes. So this energy is giving off to the environment as heat. All right, so now let's talk about the energy pyramid and further. So the consumers at the top of the food pyramid have much less energy available to support them than those closer to the bottom. That is why their numbers are relatively few. So because they end up not having anything to eat, some top predators or apex predators may end up dying because one, they're not getting as much energy, and two, they need to eat multiple things for them to get that energy. So eventually the amount of energy left cannot support another level. So you may end up stopping at the second level consumer or even the tertiary consumer and not go further to the quaternary consumer, okay? All right, so here, think about this question. Biomass is the energy in living organism. It decreases from the lower to the higher trophic level. How is this possible in the law of conservation of mass? Says that the mass can neither be created nor destroyed. Okay, so think about it. So this is like you're gonna have to think a little bit harder on this. The answer may not be as evident as you may think, okay? So just think about it, type in your answer there, okay? So here is a quick little activity. So you need to drag and drop the terms below to their correct locations. Some terms are repeated and will be placed in multiple locations on the energy pyramid. Okay. Next, use the shape tool to draw arrows illustrating the flow of energy. Okay. So go up here to the shape tool, find the arrows, and use one of these curved arrows this curved arrow to figure out how should energy be transferred, okay? So you should be using each of these, and then you should be using one of these, and then you should be using one of these in each level, okay? Any questions, just let me know. Finally, explain the trophic levels in the energy pyramid. Explain the movement of the initial arrow from the sun through the energy pyramid, and then differentiate between the amount of initial energy from the sun at the producer trophic level versus the apex predator trophic level, okay? So tell me what the initial energy is from the producer part versus the apex predator's energy level. And then lastly, you're just answering the essential question and telling me if you understand everything or if you need any help. So if you still need questions, still have questions, so forth, let me know. All right, at this point, all of your notes should be filled in. All of the block boxes should be filled in, and you should be gluing these notes into your journal. Thank you.